Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iman bin Ismail, and for today I am going to present my bachelor degree project, which the title is to design and fabricate motor assist system for fin drive foot pedal kayak. This is about myself. I am from 4 BMMA 2/1 and from FTKMP, and this is my supervisor. I am Mazlan bin Ahmad Mansor. So, for the introduction, kayaking is a sport activity characterized by exceptional demands on upper body performance, and nowadays, modern kayak have grown into various categories such as racing kayaks, surf kayaks, fishing kayaks, and others. So, for the problem statement, it is undeniable that kayaking, apart from being a pleasurable and enjoyable sport, has many health and mental benefits. However, as people get old, their physical well-being such as strength, stamina, agility, and flexibility drops, which making everyday tasks and normal functioning more difficult for the elderly. So, for the project objective, the first one is to design a motor assist system for fin drive foot pedal kayak by using Kayak software. The second one, to fabricate a motor assist system for the fin drive foot pedal kayak with the help of motor powered by a battery. And the last one is to reduce the conservation of human energy. For the scopes of project, the first one is to invent and fabricate the motor assist system for the fin drive foot pedal kayak. Next, the type of mechanism and motor that will be used to move the foot pedal fin drive system. And the last one is to allow additional features by equipped with motor assist for the pedal. So, next, the literature review based on previous related work. It starts with the evolution of kayak. In 1800, kayak was first introduced in Europe, and one of its design was called boat, which was invented in Germany. In 1950s until 1960s, Percy Blackfoot designed and produced hundreds of canvas-covered plywood and wooden kayaks, which popularized sea kayaking. And in 1936 until 1972, kayaking as a competitive sport began during the Summer Olympic Games in Germany. There are three types of kayak propulsion, which is the first one is pedal kayak. The pedal kayak is held with two hands. And next, pedal fin drive. The pedal fin drive is a pedal-powered device that uses two identical fins that move forward, backward, and sideways. And the last one is the pedal propeller drive, which is used to propel a propeller-based pedal kayak forward or backward. Next, this is the theory of four-bar linkage. The four-bar linkage, generally known as the most direct closed-loop linkage, which consists of four members with three moving links, a fixed link, and a four-pin joint. Four-bar linkage have many categories, such as crank and rocker, drag link, and double rocker. This is the Grashoff criterion, and it stated that if the sum of the shortest and the longest link of the planar quadrilateral linkage is less than equal to the sum of the remaining of the two links, the shortest link can rotate fully with respect to a neighboring link. Next, methodology. This is my flowchart for my project, and the flowchart will be used as a reference and guidance throughout the project's development. Next, the survey response. A survey has been distributed to a random group of people through social media, and it comprises 8 questions that the respondent must answer. After that, the survey answer has been recorded, and the response is very important to translate the data into house of quality table before design selection. This is one of the raw designs. For design A, the basic mechanism used in this design is 4x linkage. Next, for the design B, the basic mechanism used is quick return mechanism. And the last one, the design C, Scotch yoke mechanism is applied to the motor assist, which is the basic mechanism is Scotch yoke. Okay, this is the house of quality. So based on the figure, design A is in the leading position while design B and C are in lagging position. And based on the figure, the simple mechanism is the most essential for the customer requirement and needs. And the product does not have to be fast because it has the minor importance than the others. And the primary goal of this HOQ method is to fulfill the customer requirements, which a simple mechanism, a proper safety structure, and a long-lasting construction for motor assist kayak that is more flexible and stronger. For the Grashoff criterion, and based on the measurement that has been recorded, the calculation was made before the design concept in Kayak V5 and the fabrication process. From the result, theoretically, it is possible to achieve the design of the crank rocker mechanism for the motor assist kayak because the sum of S and L is less than the sum of P and Q. This is my 3D design on Kayak V5 software. As you can see, this is the assembled parts of the 3D design. And this is the drafting of the part designs. So for the fabrication process, it starts with buying raw materials, and then the raw materials were brought to the workshop for the cutting process based on the drafting design. After the cutting process, the parts were drilled by using a drilling machine, and after the drilling process, the long shaft, the sprocket, the mounting parts are welded by using metal inert gas, which is the MIG welding type. Next is the first test with assembled part, which connected to the power source. This is because if any flaws happen, such as the welding crack or the holes made does not fit, it can be fixed immediately. The next process is the finishing process. After polishing the product by using sandpaper and grinder machine, aerosol spray pen is applied to the product. And this process uses different types of aerosol spray pen, which is matte black, metallic black, and clear. This is the result and discussion. So the result is after finishing the fabrication process, which is the finishing process, the product was assembled to the kayak provided. And field testing. Field testing aims to guarantee that the product is functional and can work efficiently. And the distance for each test was 50 meters, and the time it took for the kayak to reach the finisher was recorded by using a stopwatch. This is the result from the field testing. So based on both tables, it can be concluded that the kayak equipped with motor assist system has a much lower value in terms of speed than manually pedaled in 50 meters. A motor assist system needs more time to travel at a certain distance than manually pedaled. So, as for conclusion, although it is not fast as pedaling by foot, it demonstrates that the project has been completed effectively along with the previous calculation and methodology. There are some reasons why the kayak equipped with the motor assist system move slower than if pedaled manually, such as the lower speed of the wiper use, the power required for the motor to overcome the force of the water, the presence of the wind, and the weight of the kayak as well as the driver. And based on the result findings, it can be determined that this project was completed successfully and all the objectives were achieved and method used in the literature review were proven. This is my bachelor's degree project 1 and 2 Gantt chart, and that's all from me. Thank you.